In this lecture, we discuss about some examples of a non-empty set in which some addition and multiplications, scalar multiplication are defined, but they are not a vector space. Let us take the first example. Let V is equal to xy, xy belongs to R, and y is greater than 0. Means here, the value of y is always positive. Let A, B, C, D belongs to V and K belongs to R. Define A plus AB plus CD, which is equal to A plus C, B plus D, and K times of AB is equal to KA in and B to the power K, so that V is not a vector space. So if the question comes like this, we have to only show at least one property which is not satisfied by this set. So closure axiom satisfied over here, associative law satisfied, additive identity not satisfied. Why it is not satisfied? Because here it is said that y is always greater than 0. So 0, 0 will not be the element of this set. Therefore, it is not a vector space. Similarly, we can also prove that additive inverse is not satisfied because minus if A, B belongs to V, then minus A minus B is not belongs to V because Y should not be negative. So out of these two properties, if we are able to prove at least one property, then we are able to say that the given set of element is not a vector space. Hence, V is not a vector space. Let us take one more example. Let V is equal to 2 by 2 matrix A, B, C, D, such that A, B, C, D belongs to R, and the condition is AD minus BC is not equal to 0. Now we have to check whether V is a vector space or not. Again, we will only check that property which will not satisfy this property. So let us take the closure axiom. Let me take two different element, 1, 2, 3, 4. So if we multiply this, 1 into 4 is 4, 3 into 2 is 6. Clearly, AD minus BC is not equal to 0. Similarly, minus 1 into minus 4 is 4, which is also not equal to plus 6. So we have taken two elements on V. Let us adding them. If we add them, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, we are getting 0, 0, 0. Since if we multiply 0 into 0 is 0, minus 0 into 0 is 0, which is equal to 0. Since this element is not element of V, we have taken the two element 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, which are element of V, but the resultant value element is not element of V. Therefore, it does not satisfy closure axiom. Hence, the given set of elements is not a vector space. Let us take one more example. Let V is equal to same matrix we have taken, but in this example, AD minus BC, which is equal to 0. So let us also give some counter example over here. Let me again take two element, 1, 2, 1, 2, minus 1, 2, 1, minus 2 belongs to V. Then let us add that two element, 1, 2, 1, 2, and minus 1, 2, 1, minus 2. 1 minus 1, 2 plus 2, 1 plus 1, 2 minus 2. 1 minus 1 is 0, 2 plus 2 is 4, 1 plus 1 is 2, and 2 minus 2 is 0. If we simplify it, we are getting 0, 4, 2, and 0. Now if we multiply it, now look here, 1 into 2 is 2, minus 1 into 2 is 2. So 2 minus 2 is 0. Similarly, minus 1 into minus 2 is 2, minus 1 into 2, which is equal to 2, which implies 2 minus 2 equal to 0. These two elements are element of V, which satisfy this property AD minus B is equal to 0. But the after adding these two elements, that this 0 into 0 is 0, minus 2 into 4 is 8, which is not equal to 0, which is not element of V. Since it does not satisfy the closure axiom, therefore this V is not a vector space. Let us take one more example. Let V is equal to R square and operation x1 y1 plus x2 y2, which is equal to x1 plus x2, y1 plus y2, and k times of x1 y1, which is equal to k times of 2k x1, 2k y1. Check whether V is a vector space or no. So if we want to prove that it is vector space or not, we have to check only one property which shows that it does not satisfy all the properties of the vector space. If there are 10 properties of vector space, so out of that 10 properties, if we are able to prove or disprove at least one property, then we are able to say that it is not a vector space. Now we know that what is the 10th property of vector space? It is unitary law. Unitary law says that 1 into x, which is equal to x, for all x belongs to V, then this is called unitary law. In this example, let k belongs to R and xy belongs to V. Then according to the definition, kx1 y1, which is equal to 2kx1 2ky1. Here k times of xy, which is equal to 2kx 2ky. Let us put k equal to 1. We have 1 into xy, which is equal to, we have to put k equal to 1. So 2 into 1 into x and 2 into 1 into y, which gives us 2x to y, which is not equal to xy. As per the unitary law, 1 into x should be x. So 1 into xy, it should be xy. But here, in this example, we are not getting 1 into xy is equal to xy. So therefore, 1 into x is equal to x for all x belongs to V is not satisfied. Sorry, here not is not satisfied. Therefore, V is not a vector space. Thank you.